Okay, here's some proofs from section 4.4. And if we kind of draw this sketch out, and by the sketch, the little red marks on the sketch, they kind of told you what was given, so I just filled this in so we can kind of adapt this until I get a chance to make up some proofs for you. Okay, so we'll take a look at this. And again, we're told that BC, we're given that BC is congruent to DA, so I actually can mark that in now. BC is congruent to DA, and AB is congruent to CD. We want to prove the triangle ABD is congruent to triangle CDB. Now check the correspondence to make sure that works. BC is here, and then DA is here, see? So that should line up. And then AB and CD. So looks like the correspondence is right. So let's go to the proof. And probably the technique we're going to use will be side, side, side. I think they actually even suggest that. So the first thing we do is we write down our givens. BC is congruent to DA. Those are segments, and that's given. And then we also have AB is congruent to DA. Oh, I'm sorry. AB is congruent to CD. AB is congruent to CD. Let me fix that up right here first. There you can kind of fudge it a little bit. AB is congruent to CD. I'll put the C here. And that's given. So we kind of survey what we've got, and we've got two sides. This is a side, or two pairs of sides. Okay, side, side. So we need one other side, and we notice that this is my one triangle, ABD, and this is my other triangle, CBD, and notice how they both have the same side, BD. That's a common side. So it's in both triangles. And it's congruent to itself by the reflexive property, so that's going to be our third side. So we would say that BD is congruent to itself, BD, and that's by the reflexive property of congruence. We've also got one of these reflexive properties for equality. So I'll mark that with 3 marks, because that's my third side. Put a side here, and it looks like I've got side, 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 so therefore I've got what I'm trying to prove. Triangle ABD is congruent to triangle CDB, and the reason is side, side, side. And there you go. Okay. All right, let's take a look at another one. Number 3. And again, we had to kind of expand this a little bit so it makes sense. So I drew my sketch. This is my given, and I'll write this in again. MN is congruent to MQ. Oops. Should be an M over here, excuse me. So MN is congruent to MQ, so I can put one little mark there just to kind of remind me. And then NP and QP are congruent. And we want to prove the triangle MNP. MNP is congruent to triangle MQP. And you can see how the MN and MQs line up, and the NP and the QP line up. So it looks like our correspondence is written right. So let's get to it. So first of all, we'll write down our given. MN is congruent to MQ. That's given. And those are segments. And NP is congruent to QP. That's given. And those are two sides. And our strategy will probably be to get side, side, side. And again, if we look at these two triangles, MNP, there's MNP and MQP, MQP. You notice we have a common side in both triangles. The side MP is in this triangle, and MP is in that triangle. So we can use that as our third side because it's equal to itself, or congruent to itself, equal in measure to itself. So we can say that MP is congruent to MP, and that again is the reflexive property of congruence, and that gives me my third side. So I can now finish it up because I've got side, 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 so the two triangles are congruent by side, side, side. So triangle M and P is congruent to triangle M, Q, P by side, side, side. Okay, so not too bad. Oops, I forgot to mark this up here. Excuse me, 3 marks. So there's my side, side, and side. Okay, so hope those help.